Welcome, dear learner. We are discussing about the arrays and pointer in a C. In a previous lecture, we discussed about what is an array and pointer. Friends, in this lecture, we have to see C programs on arrays and pointer. Our first C program is program to calculate minimum number using array. Second C program is program to generate Fibonacci series using array. Then third C program is a program to sort number in ascending order. Fourth C program is a program of pointer expression. Fifth C program is a program to illustrate use of asterisks to assess the value. Then sixth C program is a program to illustrate array name as a pointer. Program number 7 is program to illustrate of basic use of a pointer. All this program we have to see one by one. First program is a program to calculate minimum number using array. This is the command line. Hash include is a preprocessor directive. stdio means standard input output dot h means header. Then main function. Then integer. I is a integer number. Now we have to consider one array. The name of array is number. Okay, NUM. This is the name of array, and this array consists of a 10 element. This is one dimensional array, and all the numbers are integer. Now clear screen, which is used to clear the previous output. Then printf enter any 10 integer. This message is displayed on a screen by using printf function. Now we use a for loop. Now we have to enter the 10 integer. Okay, we use a for loop for I is equal to 0, which is initialization, I is less than 10, which is the condition, and I is incremented. I is started from 0 and it is incremented up to 10. Okay, now when this loop is executed, when this condition is satisfied, that is I is less than 10, then the loop is executed. That is, now we have to enter the number 10 number. Okay, 10 number. For that we use the input function, that is a scanf function. All these 10 numbers are integer, and therefore we use percentage %d and num I. Okay, I is started from 0 and it is less than 10. We have to enter the I. Okay, number I up to the condition is satisfied, that is I is less than 10, and then I is incremented by 1. Now again we use a for loop. For is equal to 0, I is less than 10, and then I is incremented. Now we have to check some condition. For that, if number I is less than number I plus 1, okay, number I is less than number I plus 1, okay, if this condition is satisfied, then the number I plus 1, it is assigned as number I. Okay, if number I is less than number I plus 1, then number I plus 1 is assigned as a number I. Okay, now we have to print that a number, minimum number, that is minimum number is equal to percentage %d, which is the integer, and number 9. Okay, number 9, that is a size of a array. 9 represent the size of a array. Okay, get ch. So this is a very simple program. Our second program is a program to generate Fibonacci series using array. Fibonacci series means first number is added in a second number so that we get third number. Then second number is added in third number so that we get fourth number. This process is carried out up to the last term of the Fibonacci series. Okay. Hash include is again preprocessor directive. stdio.h main function. Then integer I is integer. N the number. Okay. N is integer. Fibonacci FIB. This is the name of the array. 30 is the size of an array. That it indicates that it consists of a 30 elements. Okay, clear screen, which is used to clear the previous output. Now printf, which is used to display the message on a screen, that is enter number. When this message is displayed on a screen, we have to enter the number by using scanf function. For that we use scanf percentage. Why percentage? Because n is a integer. Now by using this input function we enter n. Okay, enter n. Then first term of the Fibonacci series is considered as a 0. Therefore FIB 0, that is the first term. Okay. This is also first element of the array. It is equal to 0. Then second element of array, that is FIB1 is equal to 1. It indicates that the second term of the Fibonacci series is 1. First term is a 0 and second term is a 1. Okay. Now we have to consider one of for loop. For that, for I is equal to 2, this is the initialization. Then the condition is I is less than n. Okay. The n is a number up to which we have to generate the Fibonacci series, and I is incremented. Now Fibonacci, that is FIB I. Okay, here we initialize I is equal to 2. Okay, that is we get third term of a Fibonacci series, and this third term of a Fibonacci series, it is equal to FIB I minus 1, means 2 minus 1, it is 1. So FIB 1, but FIB1 is 1. FIB I minus 2, it indicates that 2 minus 2 is 0, but FIB 0 is 0, so that 1 is added in 0, or simply we can say that 0 is added in 1, so that we get third term of a Fibonacci series, that is FIB2. This process is carried out up to I is less than n. Okay, now we have to print the Fibonacci series. So print a Fibonacci series. For that we use one for loop. For I is equal to 0, this is initialization. For I is less than n, this is our condition, and I is incremented. Now printf percentage 5d, this is a formatted output. Okay, Fibonacci I means it display the element. Okay, it display the element up to number n, that is it display first element 0, second element 1, third element 1, then fourth element is 1 plus 1 2. So this process is carried out. Okay, and for that we use printf function, which is the output function get ch. Okay, now Fibonacci series, our output is enter the number, that is n, which is 6. Okay, So the Fibonacci series consists of a 6 term. F0, FIB0, that is first element of a array is 0, which is a first term of a Fibonacci series. FIB1 is 1, which is second element of array and second term of a Fibonacci series. Now first term is added with second term, that is 0 is added in 1, so we get third term of a Fibonacci series, that is 1. Now second term is added in a third term, we get fourth term. Then third term is added in a fourth term, we get fifth term. Then the fourth term is added in a fifth term, we get term 6 of a Fibonacci series. Okay, now we have to sort the number in ascending order. In this program we also use array. Again, hash include stdio.h. Hash include is a preprocessor directive. Hash in stdio.h is a standard input output .h header file. Main function, then integer, I is integer, j is integer. Temporary, this word is used in a program which is also integer. N is a integer. Now integer as, that is it represent ascending. 10, as is name of the array. 10 represent size of array, that is this array consists of 10 element and all these 10 elements are integer. Integer is a data type. Okay, clear screen, which is used to clear the previous output. Printf, how many number are arranged? This message is a display on a screen by using printf function. Now we have to enter the number. Okay, for that we use input function scanf %d. Why %d? Because the number which enter n is an integer. So scanf %d and n. Now printf enter the number. Again this message is a display on a screen. We use for loop for I is equal to 0, which is initialization. I is less than n. This is the condition and I is incremented by 1. I is started from 0. It is incremented by 1 and this is carried out up to n. I is less than n. Now this loop is executed, for loop is executed up to the condition I is less than n is satisfied. And when this condition is satisfied, we enter the terms of different terms. Okay, and all these terms are integer. Okay, %d, which scanf, for that we use the input function scanf. Now we have to enter the different value of I. Okay, it may be anything. Okay, but only all these term must be 10. So the array consists of 10 elements, so that the total terms are 10. Okay, and all are integer. %d and as, that is ascending, I. Okay, we enter the different terms by using this scanf function. Now we again use for loop. For I is equal to 0, I is less than n minus 1. Okay, initialization, condition, then I is incremented by 1. Now I is less than n minus 1, this for loop is executed up to this condition is satisfied, that is I is less than n minus 1. Okay, again there is a loop inside the loop, that is a for loop. Okay, that is a nested loop, nested for loop for j is equal to I plus 1. Okay, j is less than n and j is incremented. Initially we consider I is equal to 0. So 0 is added in 1. So we get j is equal to 1. Okay. J is, so initial value of a j is 1. And now j is incremented up to n. Okay. Now we have to check the condition. If ascending as I is greater than asj, okay, in first for loop we use I is equal to 0, but in third for loop we use j is equal to I plus 1, that is 0 plus 1, so j is equal to 1. And now we have to check the condition. If ascending I is greater than I ascending j, okay, if this condition is true, then the statement below the for loop, below the if statement is executed. Okay, now we have to check the condition. Now temporary as I, okay, then as, that is ascending I is equal to ascending j. Ascending j is considered as a temporary. Okay, and this closing curly brackets are used to close 3 for loop. Now we have to print the ascending order. For that we use the output function, that is a printf number of ascending order. Okay, for I is equal to 0, I is less than n, and I is incremented. Again the output is a formatted output, and therefore we use percentage 4d, okay, slash t, it is a use for horizontal tab, and ascending I, which is a use to display the the output of a ascending order, and the get ch. Okay, how many number are arranged? 4 number. Okay, enter the number -6, 15, 2, -12. These 4 numbers are entered. Okay, then number in ascending order -12, -6, 2 and 15. Okay. Now C program of a pointer expression. Hash include stdio.h main function, then opening curly bracket, integer a is equal to 12. Asterisk pointer, asterisk pointer, it is a integer, so data type is a integer, and a is equal to 12. Clear scanning, which is used to clear the previous output. Now pointer is equal to address of a. Okay, pointer is equal to address of a. We use the address operator. Okay, now the pointer, okay, asterisk pointer, it indicates that it is the pointer, it is incremented by 3. Okay, now we have to print or we have to display. Okay, for that we use percentage u, percentage d, pointer, and asterisk of a pointer. Okay. Here we use percentage u because the integer is unsigned integer. Pointer is unsigned integer. Okay, get ch, very simple. Output is 65524. Actually, this is the address. This is the address. Okay, address. Okay, where 12 is saved, and now the pointer get this value, and this value is incremented by 3. Okay, pointer is equal to address of a. Okay, so it display the address 65524. This is the address. Okay, asterisk pointers, it is equal to point that address. Okay, so asterisk pointers point that address, get the value from that address, and this value is incremented by 3. So 12 is incremented by 3 and we get value 15. Okay, very simple. Now program to illustrate use of asterisks to access the value. Again, hash include stdio.h main function. Okay, integer a is equal to 2, clear screen. Then again we use a printf function. Address of a is equal to percentage u. Why percentage u? Because it is unsigned integer. Okay, and a. Okay, now this printf function is used to display the address of a. Okay. Value of a is a 2. Okay, the address is different. Okay. Now value of a is equal to percentage d, which is integer, and a. This printf function is used to display the value of a. Okay. Now printf /n is used for new line. Value of a is equal to percentage d and a. Okay, get ch. Very simple. Output is address of a is 65524. This is address. Okay. Value of a is 2. Value of a is 2. And by using third printf function, we display the value of a, which is equal to percentage d. Okay, value of a at the address of a, that is at address 65524, the value of a is 2. We initialize the value of a is 2, and at the address a, value of a is 2, so that by using third printf function we display the value of a on a screen, which is 2. Now program to illustrate array name as a pointer. Again, hash include stdio.h main function, then integer array 5, arr, this is the name of array. 5, this represents size of array. It indicates that the array consists of the 5 elements, and the data type is an integer, that is all elements are integer. Integer I, and clear screen, which is used to clear the previous output. For loop I is equal to 0, I is less than 5, and I is incremented by 1. Okay. This loop is executed up to the condition I is less than 5 is satisfied. Okay. Printf percentage u contain percentage d. Percentage u contain percentage d. Now /n is for a new line. Array plus I. Pointer. Asterisk represent pointer. Array plus 1. Okay. I is 0. Okay, I is 0. Then we take elements of a array, and these elements are 1, 2, 3, 4, 5. Okay, so that I is less than 5. This condition is satisfied up to I is less than 5, so that we take all elements of a array. Okay, and then there is a particular address. Okay, get ch, then the result is output 65516 contain 1. Okay, this is display by using printf function. Percentage u contain means 65516 contain. Percentage d means 1. Okay, now this address is incremented by 2. Why address is incremented by 2? Because it is of a 2 byte. So 65518 contain 2, that is the second element of array. 65520 contain 3, that is third element of array. 65522 contain 4, that is the fourth element of array. 65524 contain 5, this is the fifth element of a array. Okay, now program to illustrate basic use of a pointer. Hash include stdio.h main function, then declaration. Now we have to declare. Okay. Integer n is equal to 20. Okay, n is equal to 20. Asterisk pointer n. Okay, n is equal to 20, which is an integer. Asterisk pointer, which is also of a data type. Pointers n, the address of n is assigned as a pointer n. Okay, clear screen, which is used to clear the previous one. Now we have to display the value. For that we use output function, that is a printf /n for new line, direct access value is equal to %d. Okay, and this printf function is used to display the value of n, which is equal to 20. Okay, so direct access value is equal to 20 is a display on a screen. Indirect access value is equal to %d pointer. Okay, now display the address. Now we have to display the address. So we use a printf function, direct access address is equal to %u, which is an unsigned integer, address of n. Okay, address of n, that is the value n is equal to 20 is stored. We have to display the address of that value. Indirect access address of %u, again we have to display the address of the pointer. Okay, now modifying the value. Now we have to change the value, and for that we consider n is equal to 30. Direct modification, value is equal to %d. Okay, %d n pointer. Okay, which is used to display the value n and pointer n. Pointer 15. Indirect modification. In first case we modify the value direct, and in second case we indirect modification, and for that we consider pointer is equal to 50. So printf indirect modification value is equal to percentage d, okay, percentage d and get ch. What is the output of this? Direct access value. First printf function is used to display value n is equal to 20. So direct access value is equal to 20. Second printf function is used to display the value of n, okay, which is indirect access and the value is 20. Now we have to display the address, okay, and by using direct access, address is a 65524. Here the address at which the value 20 is saved. Indirect access address is again same 65524. Now we have to modify the value of n, and for that we consider n is equal to 30. Direct modification value is equal to percentage d. So 30 is a display. Again percentage d, 30 is a display. Indirect modification. In indirect modification, we change the value, that is pointer. Pointer is equal to 50. Okay. And we change the value of that address, okay, by using indirect modification, and the value is a 50 and 50. Okay. Value n is equal to 50 and pointer, at the pointer there is also value. Okay. So this is the modification. Okay. So all these are a very important program related to array and